Welcome to bulletgenie.com. Today we are going to answer a few questions that were asked at the Washington State 3-gun a couple weeks ago. The first question was, can you sort by TD rather than just extreme spread? Can you incorporate the TD into the extreme spread for sorting? Let's go ahead and address that.
So, no, you shouldn't. What the test deviation, the TD reading on the machine is telling you, or giving you an indication of, is how smoothly the machine is conducting its series of tests. Alright, so every time you press the button and you spin a bullet here, the machine is taking 1,350 samples in 3 groups of 450. So in other words, as that bullet is going around, it's conducting 3 tests, each of 450 measurements, and what it's looking for is the extreme difference between the lowest reading and the highest reading. Okay, what the test deviation tells you is how consistent those low and high values are between those 3 sets of measurements. Okay, and the reason that's important is if there's something going wrong with the machine, in other words, maybe you've got some dye wax or some grit on your bullet, the drive ring is gummed up, something is not adjusted properly, you'll see a large test deviation value, and that's your notice to check out how it's operating, make any adjustments, clean the bullet cradle, make sure that everything is spinning smoothly. Okay, so it's not something that you want to bend the bullets on. Okay.
And the test deviations, if they're like 6 to 5.5, somewhere in there, you've got a good sample. So don't worry about a test deviation that's 0.1 or 3.5. You're still going to get like an 18 or a 30 or whatever you're reading for the bullet you're testing. You're just going to go ahead and bend your bullets. So don't get too hung up on test deviation. Test deviation, as we just talked about, is the quality of what's going on. But we're going to bend on extreme spread. Always bend on extreme spread.
Yep.
Okay, another question that was asked was, are you manipulating the machine to get the reading you want? Let's address that.
So, no, we're not. The idea is you get the machine set up to where it's running smoothly for that particular size or that caliber of bullet, that weight of bullet, all right? And then you're just testing them, okay? And you're binning bullets based on the extreme spread. You're creating your histogram, all right? What you are adjusting is the operating point, and I think what we'll do here is we'll bring the camera in so you can see the numbers, and we'll play around with the knobs on the machine, the coarse and the fine adjust, and show you that even though we're changing the operating point, which is what the little indicator on the screen represents, we're not changing what the machine will read in terms of measuring the bullet. So, as you can see here, we've got a 105 grain 6mm bullet in the cradle. We've adjusted the machine so that it spins smoothly and everything's running nicely. Okay, I'm going to press the test button here and we'll get an initial reading. 37, 37, 37. Test deviation of 0. Okay, so in this case, all 3 sets of measurements return the same extreme spread. Okay, that's why you have a test deviation of 0 there. Alright, so that ran very, very smoothly. Now, what I'm going to do is I'm going to go ahead and adjust these knobs to shift the operating point and show that, give the machine a couple of seconds to reestablish an equilibrium, you should get the same reading. Okay, so the knob on the left with the red indicator is our fine adjustment. The knob on the right with the off-white indicator is our coarse adjustment. Alright, so as mentioned in the manual, you want the operating point indicator to be right in the center of the screen, give or take. Alright, we're a little high right now. So what I'm going to go ahead and do first of all is let's run the bullet one more time. So it's 37, 37, 37. I'd like to get a little bit of test deviation. Here we go. 38, 38, 37, 37 with a 0.8 test deviation. Okay, so a little bit of variation there. That's a great test deviation number. Perfectly happy with that. What I'm going to go ahead and do is I'm just going to turn the fine adjustment knob down and move our operating point indicator a couple of clicks to the left. And then I'm going to run this again. 36, 37, 37. Okay. 36, test deviation of 0.8. So we're within 1, which is what the machine is designed to do. Okay, we're taking an analog signal and we're converting it to digital. So there's always a little bit of fluctuation. That's perfectly fine. All right, let's go ahead and raise this all the way up. So we're going to move the operating point up about 3 clicks. Okay. Now, one thing that if you're testing your bullets, you should be doing every time you make an adjustment to the machine like this, we're back at 37, is to allow the machine a couple of seconds to come to a new operating point. Okay, so the way this works is the sensor in there and its response to whatever is in the bullet cradle determines the operating point of the machine along with your adjustment knobs here. Okay, whenever you change the caliber, change the mass of the bullet, or change the operating point with your controls here, the machine takes a few seconds to sort of re-equalize itself. It's always trying to find that best operating point. So if I adjust one of these a huge amount and then test the bullet right away, you're going to get a reading that doesn't make a lot of sense or is not as accurate as you would like. All right, so for example here, let's go ahead and adjust the coarse knob, and I'm going to turn this way down, too low there, just to we'll actually go outside of the preferred operating range, and here you can see it's too low. All right, but we'll go ahead and test it anyway. So it's a 37. Let it spin up. 37, 36, 39, 37. A little higher test deviation there. I didn't even let it have a second to re-equilibrate. Let's go ahead and turn it all the way up. Let's get it as high as it can go there, a little further. There we go. Now we're kind of on the high side of the scale. Again, you don't want to be operating at these outer limits. You want to keep that operating point in the middle. Let's run it again. 37, 39, 37, 37 with a test deviation of 1.7. Still a nice low test deviation, a nice result that you can be confident in. Okay, so you can see here that just by changing the operating point, I'm not shifting the reading. All right. Thank you for watching. BulletGenie.com will be posting more videos shortly about the use and operation of the machine.